astronomers and space enthusiasts will find Mercury, the smallest planet in the solar system, to be a fascinating subject. This mysterious world remained hidden from view for centuries, but as space exploration became more popular, it began to reveal its secrets. What else does Mercury conceal, and why is it so different from other planets? The Mariner 10 mission of NASA in 1973 marked the beginning of the search for Mercury, which was followed by the Messenger spacecraft in 2004. The first spacecraft to visit Mercury was Mariner 10, which spotted the complicated planet during a flyby. It took pictures that showed that, like our moon, Mercury's surface is full of strange craters and bulges. Mercury's surprising magnetic field, rocky exterior, and larger-than-expected core were all discovered by the mission. These results cast doubt on previous scientific hypotheses regarding Mercury's composition. Messenger, which came out 31 years after Mariner 10, helped us learn more about Mercury. Messenger, in contrast to its predecessor, was designed to enter Mercury's orbit, enabling comprehensive research on the planet. During the mission, more than 200,000 images were taken, revealing previously unknown areas of Mercury. High levels of magnesium and manganese on Mercury's dark side were one of Messenger's most exciting discoveries, raising questions about the mechanisms involved. The mission additionally showed that Mercury's attractive field is major areas of strength for exceptionally its northern districts, which is wonderful contrasted with different planets. Scientists now know that Mercury's interior structure and composition are very different from what was initially thought thanks to these findings. The movement of liquid iron in the core of most planets, including Earth, results in the formation of magnetic fields. Be that as it may, Mercury's inner construction prompts uncommon attractive way of behaving. Mercury's outrageous temperature varieties are another captivating perspective. During the day, temperatures can reach 430 degrees Celsius 860 degrees Fahrenheit, sufficiently hot to liquefy lead. Temperatures drop to -180 degrees Celsius -292 degrees Fahrenheit at night. This huge temperature variety is because of Mercury's slim climate, which does close to nothing to manage temperature or hold heat. In spite of these extremes, recent research has uncovered some surprising features on the surface of Mercury. In 2012, Messenger data revealed pyroclastic deposits from explosive volcanoes and evidence of volcanic activity on Mercury. Mercury's long-held belief that it was geologically dead was put to the test by this finding. Interestingly, water ice was also discovered in some of Mercury's polar craters in 2012, according to researchers. Even though Mercury is close to the Sun, these shadowed areas are cold enough to hold water ice. This raises concerns regarding the existence of straightforward life forms on Mercury. Could these icy regions support life, such as the Earth's extremophiles? BepiColombo, the most recent mission to Mercury, launched in 2018 with the help of the European Space Agency and the Japan Aerospace Exploration Agency. It is set to arrive at Mercury in 2025. The purpose of this mission is to collect comprehensive data on Mercury's surface, including its history and chemical composition. Mercury's mysterious magnetic field and the presence of water ice continue to awe. However, what lies ahead of you will force you to reevaluate your understanding of the dynamics of planets. Mercury's day is longer than its year. While Mercury's orbit around the Sun only takes 88 days, it takes 176 Earth days to complete one full revolution around Mercury. On Mercury, a year actually lasts only half a day. Some interesting things happen as a result of this unusual circumstance. The Sun would rise, move across the sky, set, and then rise again if you were standing on Mercury's surface. Mercury's orbital speed outpaces its rotation, which results in this bizarre dance. Tidal locking, scientists believe, is to blame for this. The Sun's gravitational pull has slowed Mercury's rotation over billions of years. Mercury's orbital resonance is 3:2, in contrast to our Moon's complete lockup to Earth. Mercury's temperature varies significantly due to its peculiar rotation and orbit. The side pointing toward the Sun is strongly sweltering, while the side confronting away remaining parts in cool dimness for extensive stretches. One of the most extreme temperature changes in the solar system are these sudden ones. The exosphere, or Mercury's atmosphere, is extremely thin. It is constantly replenished by the solar wind, radioactive decay, and impacts from meteorites. Using information gathered by the Messenger spacecraft in 2020, it was discovered that Mercury's exosphere contains more water vapor than previously thought. Mercury's surface rocks are thought to contain oxygen and hydrogen from the solar wind, resulting in this water vapor. Mercury's effect on the planet's magnetic field is yet another intriguing aspect of the planet's short year and long day. Mercury has a magnetic field that is driven by its orbital conditions and rotation, despite its small size and slow rotation. This magnetic field is caused by a one-of-a-kind dynamo effect in its liquid metal core. This magnetic field protects Mercury's surface from the solar wind, despite being weaker than Earth's. There are regions on Mercury's surface that are referred to as the hot poles, where there is a lot of heat, while other areas close to the poles that don't see the sun are very cold. Researchers have discovered evidence of water ice in these cold traps. The extraordinary circle and revolution of Mercury take into consideration these cool locales to exist in spite of the planet's vicinity to the sun. Scientists are now pondering the possibility that these strange cold traps might also contain organic compounds as a result of this discovery. Spacecraft face difficulties due to Mercury's short year and long day. Spacecraft must perform intricate maneuvers, including multiple Venus and Mercury flybys, to slow down and enter orbit in order to reach Mercury. After 9 flybys, the BepiColombo mission will use these methods and enter Mercury's orbit in 2025. Once in circle, BepiColombo will confront one more test connected with Mercury's uncommon day-night cycle. During the day, the spacecraft will have to take in a lot of heat from Mercury and conserve energy for the long, cold nights. This delicate equilibrium reflects Mercury's unique spin and orbital characteristics and is essential to the mission's success. Recent computer simulations have shed new light on how Mercury got to the point where it rotates at its current rate. According to these models, Mercury's rotation used to be faster, but it has slowed down as a result of collisions with large asteroids and the influence of the Sun. This study will assist us in comprehending not only Mercury's past but also the evolution of other solar system planets. New questions arise as we continue our research on Mercury. What part did the unusual orbit of Mercury play in the creation of Earth? These inquiries serve as a reminder that there are numerous unsolved mysteries within our own solar system. Our understanding of planetary formation and evolution is challenged by Mercury's unique properties, necessitating the development of new hypotheses. What other secrets does Mercury conceal beneath its mysterious exterior? Mercury, a small planet with a lot of secrets, continues to astonish scientists with its unusual and unexpected properties.